and the output of feedback network, which is going to be a fraction of the output signal. So this feedback network will just will not entirely pass the input from the sampling network directly. It will just take a portion of the network. So it will just take the portion of the signal and it will combine this signal with the input signal using the mixer network. Okay, so see here the output of the feedback network, which is only a fraction of the output signal, is combined with the external source through the mixer network. So mixer network will combine the signal coming from the feedback network along with the input signal source. So mixer network is just like it can be additive or subtractive also. So it will just combine the signal from the feedback network and the signal coming from the signal source. The sampling network will take a portion of output from the output side and give it to feedback network, and mixing network will add or subtract or process the signals coming from input. One is coming from the signal source input, second one is coming from the output of the feedback network. So same way how sampling network can have two types, voltage sampling and current sampling, mixing networks are also of two types, series mixing and shunt mixing. So sampling network you have two types, mixing network you have two types. So how many possible combinations are there? How many possible combinations are there? You have two types of sampling network, you have two types of mixing network. So how many possible combinations of circuits you can form with these two combinations? How many possible combinations I can form? So mixing
4, sir.
network, yes, 4. Mixing network 1, sampling network 1. Mixing network 1, sampling network 2. Mixing network 2, sampling network 1. Mixing network 2, sampling network 2. This 1 and 2 indicate the two types, okay? So totally 4 circuits are possible, which is essentially going to be the 4 types of amplifiers what we have seen: voltage amplifier, current amplifier, transconductance amplifier, and trans resistance amplifier. So we are going to give them different names based on the sampling network type and mixer network type. So other parameters don't have a say on the type of the amplifier, only the type of mixing network and what type of sampling network I am going to use, that is going to determine what type of amplifier you are going to design. That is going to define the type of the feedback amplifier which is going to be designed. Okay, so that forms the second half of your unit, so where we are going to see the 4 types of amplifiers. Mixing net based on the mixing network. Mixing network can be series or shunt. Sampling network can be voltage or current. So that is going to be the second half of your unit. So we'll see that in the second half. Now we are going to focus on the properties of this amplifier. So in the normal amplifier, I'm going to change the circuit diagram by adding these 3 additional components, right? So I'm going to analyze what is behavior of this amplifier because of adding a feedback, external feedback in the circuit. So I'm going to define some parameters. So A, capital A. So capital A is the gain of the amplifier. See, whenever there is no suffix, it indicates that it is without feedback. Okay, it is without feedback. Whenever you have feedback, you will put a suffix F. Okay, so A means it is a normal amplifier gain without feedback. You know A is going to be V0 by Vi. Okay, so output of the amplifier is V0, the input to the amplifier is Vi, so A is equal to V0 by Vi. And beta, beta is the feedback factor. And how you define beta? Beta and A are logically same, output by input. So what is the output of beta? It is Vf. Vf means feedback voltage, Vf. And what is the input to beta? Coming from the output of amplifier, V0. So beta is equal to Vf by V0. It can also be If by I0. It can also be Vf by I0. It can also be If by V0. So 4 possible values of beta is possible depending on the value of A. So what amplifier you are going to define will determine the beta also. Here you see A is equal to V0 by Vi. How to write the formula for beta? Beta is approximately 1 by A. You reciprocate this A, but instead of I, you put F. Okay, so now you can, whenever you know A, you can write beta. A is V0 by Vi. So beta will be reciprocate this and replace I by F. So beta will be Vf by V naught. So here we are considering an voltage amplifier. So everything will be having the ratio only in terms of voltage. Okay. And having defined A and beta, we are defining AF. AF is the gain of the amplifier with feedback. So AF will determine the gain of this complete amplifier, including the feedback. So AF means it is output voltage V naught divided by the signal source Vs. Whenever you consider feedback, you have to consider the source. Whenever you're writing a normal amplifier gain, you have to consider the input to your amplifier. Vs and Vi are not same because you have a mixing network in between. If mixing network is not there, then Vs and Vi will be same. But since you have a mixing network which is a part of feedback, whenever you do without feedback, you will consider the input directly going into your amplifier. And whenever you're considering with feedback, you will be considering the voltage source value Vs. So AF is equal to V naught by Vs. Vs is going to be the AC input signal, which can be current or voltage, and Vf is going to be called as the feedback signal, which can also be current or voltage. So these are the basic terminologies you should know before studying about feedback amplifiers. So A is the gain of the amplifier without feedback. Gain, it is output by input. Output is V naught, input is Vi. Beta is called as feedback factor or feedback ratio. It is also output by input. Output of beta block, you see it is Vf. Input to beta block, you see it is V naught. So beta is equal to Vf by V naught. AF represents the gain of the feedback amplifier. So AF is going to be output by input. Output is V naught. Input, you have to consider the source Vs. If this mixer network is not there, then AF and A will be same. But since the mixer network is available here, Vs and Vi are not same. So we have two gains, A and AF. A is without feedback and AF is with feedback. Vs is going to be the input AC signal and Vf is going to be the feedback signal. Okay, so understand the basic terminologies. Any queries you have in the basic terminologies of the amplifier? Any queries you have?